Hello and welcome to this video where I'll explain exactly how to solve any ODE of this form, but if you're more looking for just the practice problems, I'll have every timestamp for every practice problem already in the description so you can skip around. But if not, I'll explain a little bit about what this ODE is, and then I'll go into what the three different kinds of general solutions look like when you're dealing with a constant coefficient, linear, second order, homogeneous ODE. And so that's just a mouthful, but really all it means is you just have derivatives and a variable and everything else is a constant. So in this case, we're focused on finding the general solution of y. And so we need to make sure that in front of every instance of y or a derivative of y, there's only a constant. And here that is the case because a, b, and c are all constants. And so that's just what it means to be a constant coefficient. Linear because no constant is to another higher power, and then second order because of this second derivative here. And then homogeneous just means it's equal to 0. So really it's a lot of words to describe something that's not too complicated. But there's a couple different forms the general solution to this ODE can take, and so I'll explain exactly how to get to each one and in what situations you'll use what form. But the most important thing to realize is that when it comes to these ODEs, there's something called the characteristic equation. And so I'll denote that with just a CE. And a characteristic equation is just you're rewriting the ODE, but instead of a derivative, you just use a new variable. So let me show you what that looks like. It's pretty conventional to use r. So instead of d squared y dx squared, the second derivative of y, I'll say, no, that's r squared instead. And so typically, r is just the same power as the order of derivative that it's representing. So this will be br plus c equals 0. And that's again because that's a second order derivative, first order derivative, first power. And then here there's no derivative, right? So we can think of that as a 0 power, which would just be c times something to the 0, which is just only c. All right. So once you get your characteristic equation, at that point, you're going to need to solve it for r. So then you're going to want to solve for r. And when this happens, there's a couple of different outcomes. So I'll call it case 1. So in case 1, this is when you have two real and distinct roots. Now remember, this is a quadratic equation, so very, very often it'll have two roots. And so it's a case 1 ODE if you solve the characteristic equation and you have two different and real roots. So that's to mean that they're not the same number and they're not complex numbers. And if you run into a case 1 ODE, then the general solution looks like this. Just like that. And so C1 and C2 are just arbitrary constants. As you may have noticed in ODE, a lot of times the final solution involves an arbitrary constant, and in this case, this is how we take care of that. And then R1 and R2 are the two real and distinct roots. So you can call whichever one you want R1 and whichever one you want R2. And then if you just plug into this formula, you'll have the general solution. And so another thing that could happen when you solve this quadratic that's created by the characteristic equation is you just have one real root. And so if this is the case, this is what we call a double root situation. And so this is just a different form of a very similar general solution. This gives us C1 e to the rx, remember because there's only r in this case, there's no r1 or r2, plus C2, and then the only real difference here is there's an x here, e to the rx. So that's what happens if you solve the quadratic and there's only one root. The other thing that could happen is case 3, and this is when you have imaginary roots. And so typically this happens because of the quadratic formula, because if you remember, the discriminant is the square root of b squared minus 4ac. And so if b squared is less than 4ac, then you're taking the square root of a negative number, and therefore you have some form of an imaginary number. Now if that happens, then you're left with roots in this form. So alpha plus or minus beta I. So this is just what we call basically the end result of the quadratic equation if there is an imaginary root situation. And if this is the case, then your general solution looks like this. E to the alpha x c1 cosine of beta x plus c2 sine of beta x. And here I'll center this for you in a second. Okay, so this is what a case 3 ODE would look like when you write the actual answer down. And so if you notice, alpha and beta are not the actual roots, it's the real and the imaginary part of the root. But we'll get into what that looks like in practice in here in a second. And so we're actually going to go into some practice problems now. All right, here we have our first ODE to solve. And every coefficient here is constant. We just have a 1, a 2, and a -3. And it's equal to 0. So we can tell that this is already in the correct form. So first thing to always do is to write the characteristic equation. So in this case, that's going to be r squared. And if you write in prime notation, the actual ODE, then it's a little bit more visual why you write r squared. I kind of just think of it as like the power of your characteristic variable is the order of derivative. So in this case, y double prime turns into r squared. So plus 2r to the first power minus 3 equals 0. And that's just transferring every order of derivative into a power for a new characteristic variable in our characteristic equation. And so here, we just need to solve this quadratic equation. And so let's see, we need two numbers, would add to 2 and multiply to -3. Seems to me like 3 and 1 would do that. So let's just write r1 plus 3, parentheses, r2 minus 1 equals 0. And this is just to denote the different roots, because we can already tell this is a distinct real root situation, which we called case 1 up above. And so we have two different real roots. And this is going to give us r1 equals -3 and r2 equals 1. Okay, and once we have our two roots, then we can just kind of follow the case 1 formula. And so if we were to do that, this would give us our final answer, y of x equals c1 e to the r1x, so -3x, plus c2 e to the r2x, in this case just a 1 times x. So that's just going to give us an x right there. And that's going to be it. It's going to be the entire problem. And that's going to be our final solution to this ODE. Okay, here we are, another example. And so remember, always the first thing to do is write the characteristic equation. So we're going to have r squared plus 3r plus 2 equals 0. So then let's see if we can solve the characteristic equation for r, which is what every single one of these problems actually boils down to. Okay, so it seems like to solve this equation, we'll just factor, and that will give us r1 plus 2, r2 plus 1 equals 0, and that's because 2 and 1 add to 3 and multiply to 2. So we're just doing a quick factoring, basically right there. And so r1 then equals -2, and then r2 equals -1. And then we can plug this into our formula. Y of x equals c1 e to the r1x, so -2x, plus c2 e to the r2x, in this case -1 times x, so -1 times x, or you could just write -x to be a little bit cleaner. And so that's going to be the final answer here. All right, so again, not too bad, right? We're basically just doing an algebra problem, but calling it an ODE problem, because at the end of the day, we did just solve an ODE, right? But pretty much all we had to do was solve a quadratic equation. Okay, so let's get into another example. Okay, here we are. So first thing we want to do is write that nice characteristic equation. In this case, that's going to be 6r squared minus r minus 1 equals 0. Okay, so then we're going to solve for r. So in this case, it's going to be the quadratic equation that we use, because I don't see any easy way to factor this, or really there's no beating around the bush here. Just to jog your memory, the quadratic equation is r equals, in this case, since we're solving for r, negative b plus or minus square root of b squared minus 4ac over 2a, where each constant represents the basically order or the power in the quadratic equation. Okay, so now we just gotta plug in chug. So negative b, well, negative b is just 1, so plus or minus the square root of b squared, so negative 1 times negative 1 is 1, then minus 4 times a in this case is 6, and then times c is negative 1. Then we want to divide by 2a, so 2 times 6. So r then equals 1 plus or minus square root. Let's see, 1 minus 4 times 6 times negative 1. That's the same thing as 1 plus 24. So this is actually root 25 over 12. And so then r equals 1 plus or minus 5 over 12. And so you can see, even though we use the quadratic equation here, we're still going to have two distinct real roots. So r1, let's just choose arbitrarily that r1 is when we choose positive in the plus or minus. So 6 over 12, that's just going to be 1/2. And then r2, let's say is minus, that's going to be negative 4 over 12. So that's just going to be negative 1/3. All right, so now we just plug it into the same equation we have been using for a case 1 ODE. So c1 e to the r1, in this case we called r1 1/2 times x, plus c2 e to the r2, in this case negative 1/3 times x. And that's going to do it for your final answer. All right, let's move on to one more example of this case of ODE. Okay, here we go. So always write your characteristic equation first. So we have r squared plus 5r equals 0. Okay, so this is kind of cleverly disguising the c term and what we would use in the quadratic equation. So this is the same thing as r squared plus 5r plus 0 equals 0, where this would be a, b, and c. We could actually still factor this. We want two numbers that add to 5 but multiply to 0. So in this case, that's just going to be 5 and 0, right? So r plus 5 and r plus 0 equals 0. So then you're left with r1 equals negative 5, r2 equals 0. All right, so then let's put this into the equation we have grown to love. So c1 e to the r1x, negative 5x, plus c2 e to the r2x. So this is going to be 0 times x. And what do we know about e to the 0? That is just 1. So y of x, we can write a little bit cleaner then. c1 e to the negative 5x plus just a simple c2. And that's going to do it for the solution to this ODE. All right, here we go. So of course, write that nice characteristic equation. Gives us r squared minus 2r plus 1 equals 0. All right, let's see if we can factor this. So two numbers that add to negative 2 and multiply to 1. So in this case, well, you could just say negative 1 twice, right? Negative 1 plus negative 1, negative 2. Negative 1 times negative 1 equals 1. So actually, this is r minus 1 squared equals 0. Which means that we only have one root, and in this case, r is just going to equal 1. Okay, so this is a case 2 ODE we're working with now, but really all that's different is we have a different general solution formula. So that means that y of x still equals c1 e to the rx, in this case just x, plus c2, and then x e to the rx. And so the only difference here is this x here, and these roots are the same. Or these are the exponent x being multiplied by the roots, and those are the same. And in this case, the root was 1, so that's why you don't really see it up there. Okay, but that's still going to be the final answer here. All right, here we go. So nothing different about how we start this one out. start with the characteristic equation. So 9r squared plus 6r plus 1 equals 0. Okay, let's solve this, and to me it doesn't look like there's anything other than the quadratic formula going on here at first glance, and the quadratic formula actually isn't too bad, so we can just go ahead and do that right here. R equals negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so let's just go ahead and plug in what we know. So negative b, that's negative 6, plus or minus negative 6 squared is just 36, minus 4 times a times c. So in this case, that's 9, and then a 1 right here. And then over 2a, that's going to be 2 times 9. Okay, so then r equals negative 6 plus or minus, and then actually 4 times 9 is 36, right? So we're going to be left with negative 6 plus or minus 0 over 18, which means that if we take the plus or the minus, then we're left with the same root r. And that's going to be negative 6 over 18, which is the same thing as negative 1/3. So again, this is a double root case. Call that a case 2. And so we just got to plug it in to the general solution. E to the rx, negative 1/3 times x, plus c2x, e to the negative 1/3 times x. That'll do it for our final solution here. Let's go into another example. All right, here we go. As always, let's write out our characteristic equation. R squared minus 6r plus 9 equals 0. Okay, let's first see if this is factorable. So anytime I see that there's a coefficient of 1 in front of the r squared term, then I see if it's factorable, and if not, then I go straight to the quadratic formula. So two numbers that multiply to 9 and add to negative 6. So this is actually factorable. And so our two roots would be, let's see, negative 3 and, well, negative 3 again, because negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is 9. So this is going to be r minus 3 squared equals 0, which tells us that there's only one r, and that equals 3. And so then we can write our general solution. So y of x equals c1 e to the rx e to the 3x plus c2 x e to the 3x. And that's going to do it for our final answer here. All right, let's get into another example. All right, here we go. Let's go ahead and write out our characteristic equation here. So r squared minus 2r plus 2 equals 0. Now this is not factorable, so looks like we should just go for the quadratic formula here. So let's see, r equals negative b. In this case, b is negative 2, so negative 2 is just going to be 2. And then we have plus or minus b squared, 4 minus 4 times a times c, so like that, over 2 times 1. So r equals 2 plus or minus square root of 4 minus 8. So it's going to be a negative 4 in here, and then that's still over 2. And so this is our first example of a imaginary root case ODE, and we call that a case 3 ODE. And so we can just kind of move forward as we would, even though there's going to be an I in our equation here. What you're used to with arithmetic still works. So 2 plus or minus square root of negative 4, well, that's going to be 2 times I over 2. And then we can just write that as 1 plus or minus 1I. Okay, so remember the general solution for this ODE involves alpha and beta, but actually what we call alpha is this term right here, and what we call beta is this term right here. So this is a complex number right here, and the real part of that complex number is alpha, and the imaginary part, so it's in front of the I, is beta, and then the plus or minus you don't actually worry about here. Okay, so let's plug this into the general solution. So e to the alpha x, in this case alpha is 1, so it's just going to be e to the x times c1 cosine of beta x, in this case beta is also 1, plus c2 sine of beta x, right? But beta is 1, so this is just going to be x, and so this is going to be our final solution for this ODE. Okay, here we go. So this is very similar to the example we just did, except now there's a plus sign here. And so let's treat it the exact same way as we do any ODE of this form, and let's write out the characteristic equation. R squared plus 2r plus 2 equals 0. And now we have to solve this characteristic equation. And so here again, we're going to need to use the quadratic formula as this is not factorable. And so r equals negative b, in this case negative 2 plus or minus square root b squared, 4 minus 4 times a, in this case 1 times c times 2. And then it's over 2 times a, and a is just 1. So r then equals negative 2 plus or minus root 4 minus 8 is negative 4 over 2. And so this gives us r equals negative 1 plus or minus just 1i. And so that's because the square root of negative 4 is just 2i. So then we have negative 2 plus or minus 2i over 2, and then we divide everything by 2. We have this right here. And so remember, this is what we call alpha, and this is what we call, or I'll just say the coefficient right here. You don't include the I, actually. This is what we call beta. So let's write that out. So y of x equals e to the alpha x, so negative 1 times x times c1 cosine of beta x. So beta here is 1, so we're just going to leave it as cosine x, plus c2 times the same sine beta x, so just x. So that's going to do it for that one. All right, let's go into maybe just one more example here. Okay, here we are. So start with the characteristic equation. R squared plus 6r plus 13 equals 0. And here we just have a quadratic to solve. And again, this is not factorable, and really the only technique that would work here is the quadratic equation. So let's see, r equals negative b, so negative 6 plus or minus square root b squared 36 minus 4 times a times c, that's just going to be times 13, over 2 times a, which is just 1. So then r equals negative 6 plus or minus 36 minus 4 times 13. So what's 4 times 13? That's just going to be 52 over 2, like that. Okay, so let's move forward. R equals negative 6 plus or minus, well, what's 36 minus 52? That's just going to be negative 16, and then still over 2. Okay, so r then equals negative 6 plus or minus, that's the square root of negative 16. Well, that's just going to be the square root of 16 multiplied by I, so that's just going to be 4i, and then that's over 2. Divide everything by 2, and we're left with negative 3 plus or minus 2i, where this is what we call alpha, this term right here, and this is what we call beta. Okay, so let's write out our final answer here. Y of x equals e to the alpha x, so negative 3 times x, c1 cosine of beta x, so this is going to be 2x, plus c2 sine of beta x, so that's going to be 2 times x. And boom, that's it. That's our final answer. Okay, so we solved a couple ODEs of every case, so you can see how these really aren't too bad. It comes down to your quadratic knowledge, and typically every single problem can be solved with the quadratic equation if you'd like. So you can kind of just lean on that if that's all you want to focus on. And so if you know the quadratic equation, then these should be no big deal for you. So let me know if you have any specific questions. But that's going to do it for today's video. So thank you guys. I'll see you later.